Hi everyone, welcome back. The learning goal for this video is to identify energy as potential or kinetic and be able to convert between units of energy. So energy is defined, energy is defined as the ability to do work. It helps us make objects move and also to make things stop. And as you can see here in this example, a defibrillator provides electrical energy to the heart muscle to reestablish normal rhythm. So there's all different types of energy that we use every single day. So kinetic energy is the energy of motion, and some examples are swimming, water flowing over a dam, or working out. You can see the movement of the water that flows from the top of the dam is an example of kinetic energy. Potential energy is energy stored for use at a later time. And so some examples are the following. So the water at the top of the dam before it flows over is an example of potential energy. A compressed spring, so if you have a spring that's coiled up tightly but hasn't opened up yet, that's an example of potential energy. And chemical bonds in gasoline, coal, and food are also examples of potential energy. Once again, the water at the top of the dam has potential energy just by virtue of its position. So if we remember, potential energy is kind of related to an object's position. As the water falls over and down the dam, the potential energy is converted to kinetic energy, the energy of motion. So go ahead and pause the video, try this study check on your own, and then come back and check your work with me. So let's identify the energy in each example as potential or kinetic. Rollerblading. Good. Hopefully you said that is kinetic energy because you're moving. The energy of motion. What about a peanut butter and jelly sandwich? That's correct. This is an example of potential energy. If you haven't eaten it yet, right? We haven't started the metabolism yet. And so it is an example of potential energy. Once you eat it, then that gets converted to chemical energy. What about mowing the lawn? Kinetic. Gasoline in the gas tank. Potential. So that gasoline will be the fuel to help move our cars once we start running the car. But the gasoline itself is an example of potential energy if it's not being used yet. So the type of energy we will be working with is heat energy, and heat is the energy associated with the movement of particles. The faster the particles move, the greater the heat or thermal energy of the substance. So we use the words heat and thermal interchangeably. And we will learn in a later video that heat energy is represented by the letter Q, lowercase q. So whenever you see that, that will be heat energy, which is different than temperature. Given an ice cube, as heat is added, the water molecules that are moving slowly increase their motion. So an ice cube is in its solid state of matter. But if we put it on the table, then it's absorbing heat energy from the table, from the surroundings, and those water molecules as a solid, we're moving slowly, but as they get more heat energy or more thermal energy, they start to increase their motion. And eventually they will have enough energy to change the ice cube from solid to liquid. And a core chemistry skill that you're learning in this video is how to use different energy units. The way we express energy is either in joules, capital letter J, or in kilojoules, and 1 kilojoules, 1,000 joules, because remember, kilo represents 1,000. Or energy can be measured in calories, little CAL, or kilocalories, which would be 1,000 calories. The calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. And 1 calorie is equal to 4.184 joules. That's an exact number, so we will not need to use that value for significant figures. And you can write this equality as 2 conversion factors, which we will use in dimensional analysis. This table here shows you a comparison of energy for various resources in joules. This shows you, for example, energy radiated by the sun in 1 second. It's 10 to the 26 joules of energy. Versus, for example, energy used to sleep for 1 hour, 10 to the 5th joules of energy. All right, well, go ahead and pause the video, try the study check on your own, and then come back and check your work with me. All right, we're asked how many calories are obtained from a pat of butter if it provides 150 joules of energy when metabolized. All right, so let's go ahead and write our given. Remember, when we're working with energy in this class, we're working with heat energy. So I will write Q is equal to 150 joules. And that's for 1 pat of butter, which is about a tablespoon. And this question is asking us to calculate or to convert this value into calories. All right, so because this is a conversion, I'm going to go ahead and write what we know, that 1 calorie is equal to 4.184 joules. I'm then going to start off the dimensional analysis with the given value that's a single unit. So that's the 150 joules. So 150 joules, and then I draw my ladder here. And remember, the point of dimensional analysis is to cancel out units. And so it may be helpful to write the equality into the 2 conversion factors, and then you can choose which conversion factor will help you solve the problem. So in this case here, did you choose the first conversion factor or the second? It is the first conversion factor. Good. Because that allows us to cancel out joules, and that will leave us in the units of calories, which is what we're going for here. So if I take my calculator, I'm going to plug in and do this with me if you haven't done so already. 150 divided by 4.184, which is 35.85 calories. However, remember that with significant figures for multiplication and division, we report to the least number of significant figures. In this case, this given value is 2 significant figures. The trailing 0 doesn't count without a decimal point. So, and then these are treated as exact numbers. So we need to report the final answer to 2 sig figs. So we would round up. So the final answer would be 36 calories, and that is letter C. All right, thank you for watching, and as always, email me with any questions.